Are you able to hear what I'm trying to say?
Hello, guys.
Yeah, just give me a minute. I'll setting up. Are you able to hear me? Are you able to hear me?
Yeah, I can hear you.
Cool, cool. How are you? How
How
are
are
you?
you? Well, I'm good. Thanks for joining us on our second episode of Just Trust, our newest podcast of interviews with international teams. We are so happy that you could join. As well already said, it's the second episode, and really great that we just crossed our barriers and we're
Yeah.
talking well with you guys are all over India. So, well, my name is Angel. I'm the executives leader from Space Dragons rocketry team. And well, we'll be talking a little bit how our teams work and how we're getting ready for the IREC campaign 24. So, first of all, well, tell us a little bit about yourself, guys. Uh,
Uh,
what makes you special? What your team about?
cool, cool. So I'm hoping the audio is clear right now. There was initially a little disturbance. I'm hoping the audio is clear. I'm hoping you're able to hear me.
Yeah.
Yeah, yeah. Roughly introducing ourselves and roughly getting into our team. So, we are Team Abhyuday. We are the rocketry competition team in the institute called IIT Madras, Indian Institute of Technology, Madras. It's one of the most premier institutes of the nation. We've been ranked to be the best over since the past 7 years or so. And we started out to be the rocketry competition team of this institute. So there's a collaborative environment sphere in IIT Madras in our institute called CFI, Center for
Mhm.
Innovation. And CFI holds a lot of competition teams which participate in different competitions. Like we exist, we come to SA Cup or IREC. We have teams going into SAE organized competitions. We have teams going into IGVC or ROA challenges. So that is how the entire collaborative sphere exists in IIT Madras. So now coming to us, we were founded in during the pandemic actually, during 2021-2022 period when pandemic was running on. So we had little progress. We were trying to hit SA Cup in 2022, but due to the pandemic, we were unable to successfully participate in the competition. So we manufactured a rocket, we manufactured nose cone, we manufactured ball tube, we manufactured a couple of bulkheads, but we were unable to participate in that year's edition of the competition. So then, like after the pandemic ended, things stabilized a little bit more. And then we got people who are into rocketry also realizing about the potential of the team.
Mhm.
Like people are able to literally see a rocket standing over here, small scale one. So that is when I joined. That is when I was a freshie back then. So that is when I joined the team. And then we tried to hit for 2023 edition of the competition, Space for America Cup 2023. So in that case, yeah, in the second year, we were successfully able to compete in the competition. So we reached SA Cup successfully for the first time in 2023. And our performance was okay on some standards, and we were pretty happy with that. So we achieved a Barraman rank of 16th in that year's competition. And coming from 2023, people were motivated even more now because we had a lot to prove. Like, we had a lot to prove to different people. We had a lot to prove to ourselves on what we were trying to work out on. And yeah, then I was a member back then when we hit the 2023 edition of the competition. I eventually got promoted to lead of payload module in the team. And I started working in that domain because I was interested in it. And in 2024, we tried to go to the competition again because it's like, yeah, in 2024 edition of the competition, our performance was significantly better than what we achieved in 2023. We achieved a rank of first in Asia, and our category rank in quads was around 11th. So we were 11th among 162 teams that came in quads solid. So this is our performance with respect to SA Cup on, yeah, I'm sorry, my Bluetooth is a little loose. Uh, this is a performance in terms of SA Cup and what we try to do in rocketry. Now, coming to what we do as a whole in terms of aerospace, we work on development of engines. So currently, we're the only Asian student team to have a fully working hybrid rocket engine. So we designed, developed, and tested a hybrid rocket engine from scratch on campus facilities, completely over here in-house in IIT Madras. And we have one of our laboratories over here called Rockets and Missiles Laboratory, and we have Propulsion and Combustion Laboratory. So in these both labs, we were successfully able to fire a small scale hybrid rocket engine. We currently have an average thrust of around 220 newtons in the one which has been tested multiple times. We fired around 22 times so far, and we are looking for participating in hybrid category for 2025 SECUP. So the design ideation of the bigger engine is done, and we're currently under the phase of manufacturing of a bigger engine. Once that is done, we'll be looking forward to testing the bigger engine. So that is roughly about the team.
Wow. I mean, I'm just speechless, but well, your trajectory has been really amazing, and it has really inspired a lot of different teams. What you just mentioned and what I could read on your description, as you just said, is that you are transitioning for a hybrid, well, for a hybrid engine. Why was the transition from? Well, why you decided to do a transition from last year? You used the 10K cuts and you did great in to next year using hybrid.
Yeah. So the my team members are here in the comments. They're just pushing good stuff, I guess. Yeah. I hope they're enjoying it. So coming to the main point of it, most of our minds are into rocketry, and we basically are want to develop better tech. We want to try something new. If there's something that exists and if there's some technology which a bunch of people are trying to do, and if it excites us, then we are into it. So SACUP is a place where we try to demonstrate what we're trying to do, what we're trying to learn. So we had a propulsion module, and the co-lead alongside me of the team, his name is Arin. So he was leading propulsion back then, and he had this vision of, what if we try looking at making hybrid rocket engines or hybrid propulsion systems? Because there are even a couple of companies trying to do it. People are trying to adopt to hybrid propulsion right now, and it's something new. So why just restrict ourselves to solids? Or we are flying at quads. So we had this idea of why not go SRAD with propulsion? Why not make our own propulsion systems? When you're making everything else on our own, we have our own avionics bay, we fabricate our own rockets, we design everything on our own. So then we are like, if we make a propulsion module also, then we'll be a team which makes everything on our own. So we want to achieve that primarily. And coming to why we are not looking into solids back then, part of it being we felt if it's a hybrid propulsion system, it's something new which not a lot of people are trying, and it excited us. That is the first point. And the second being, working on solids comes with its own pieces of issues with logistics, issues with security, issues with safety, and our institute is actually very ready to support us even with that. We're actually grateful to that. But if you're having a hybrid engine, we realize you can reduce the complexity down in terms of logistics and external factors a lot. So you can put more minds into tech than more minds into worrying how am I going to take this thing to USA starting from India. More minds into worrying how am I going to get this thing working in USA. So surprisingly, our propellant is just candle wax. It's just paraffin wax, and our oxidizer is nitrous oxide, which is you can readily get it from any medical store or any hospital which uses nitrous oxide. So we had this idea ki, there are two things which someone can never imagine that they're combustible. Nitrous oxide is laughing gas, paraffin wax is candle wax. So if you go to a layman and say ki, I'm making hybrid engine out of candle wax and laughing gas, they'll say ki, nah, that's some sort of joke. But yeah, we brought it into reality. So that was again one of the major parts. So uh, yeah, my propulsion team is having fun in comment section over that. So this is the main motor behind us switching to hybrid. And as I started working on it, we realized like this is more intense, this is more interesting, and there's something new as well. So we got the ingenuity of it as well. This is how we got it into hybrid.
Okay, okay. Well, you are the only Asia team that it's going to participate in this category next year. And well, I've just seen the video from the live video from the last competition. And well, let me tell you, it was
Yeah.
right, and the video is just stunning. As for me, that I'm the executives leader here in Mexico, and I'm in charge of the video, getting everything. I mean, yours was just great. So about your rocket, uh, are you going to change a lot of things from your rocket for next year's? Are you still planning to do the different diameters next year's rocket?
Yeah. Firstly, thank you for the video part. Actually, thank you for the appreciation. Yeah. So thank you for recognizing our efforts in getting that thing done very well. And I also appreciate your effort in looking into our rocket, how it was. So I think you realized that we had a transition into the rocket last year. And last year we adopted for a design with transition because we wanted a minimum diameter rocket at the ending. So we wanted the diameter at the ending to be only as same as the quartz motor to be because we were trying to save weight. So from the design 2 years ago, whatever we had, we cut down around 7 to 8 kgs of weight by just adopting a design that is way smaller, components being way smaller, everything optimized. For this year, our major component, as I said, is propulsion system. We have our hybrid engine, we have the oxidizer tank of it. So we decided not to go with a design with transition because that is adding a layer of complexity. Over that, our engine diameter is slightly larger. We can't, the designs we're having an engine dia that's around 160 mm, the outer dia roughly around 160. So we can't afford a design with the outer dia is around 110 because the most of the quartz motors are of having they have an outer dia of 98 mm if you're considering the 98 series motor. So this time we don't have the difference of variation between the diameter of the controls module and the variation between the diameter at the engine part. So we decided adding a transition for like variation of maybe 5 to 10 centimeters is not worth it. And we don't have a transition design in our design. And coming to the major challenges part of it, I would say nothing is same as last year and this year's design. Not the propulsion, neither the avionics. The only thing that maybe is same is the profile of the nose cone. That just being standard one common. Yeah. And maybe I'd probably say the only thing that'll be common will be like the metals we use and the fasteners used. Everything in the design is just changed. Yeah.
Wow. Okay. Okay. So you're building everything. Well, most of it
Yeah.
out of. Okay. Okay. That's cool. How about payload?
So last year we had a payload called Aetorium. So what we're trying to do was we're trying to sample atmospheric constituents as a rocket descends down with help of a parachute. So we had a parachute which was giving us a terminal velocity of roughly around 5 meters per second. So what we're planning to do is we had vent holes and we had suction chambers inside the payload. So we're trying to take in air as the rocket is descending down. And then that air was being sampled in a sensor chamber, basically a gas chamber kind of thing which contains multiple sensors. And then you are trying to push that air out once the sampling part is done. We tried to implement this last year. We were not very successful with it, but we got decent enough results. So we are currently thinking to make the system better for the payload. So also the payload team is trying to target CANSAT USA as another competition. So yeah, the payload team is kind of in a grind mode right now.
Okay. Okay. Well, I'm reading here a comment from Sid that says only
Yeah,
altitude
yeah,
is the same. Well, that's great, but you're innovating in great, great new things.
yeah.
Um, so tell me a little bit. How do you work, guys? Everything that you do, it's on your university. You build it in different labs.
Yeah, as I mentioned, we have a sphere called Center for Innovation.
Mm.
So Center for Innovation for itself has a working facility. I'm currently sitting over here. Maybe after I'm done talking, I just turn the camera around. And yeah, so we have a pretty good facility to work actually. We have a pretty good facility. It's air conditioned everywhere. We have enough tools to work with. The university provides us with that. We have a workshop. It's basically a machine tools space where we can access machine tools and get manufacturing done. If something is not available over there, we get it manufactured from outside, from external vendors. And coming to the funding part of things, we get funded from the university a little, and also we have external sponsors. So it's like a decent balance of both of them. And there is an entire dynamic, a complex dynamic going on behind how we can access sponsors' money or how the finances of it work, which is basically just decided by the laws of the university. So we just stick to them. We try to get money. We do the manufacture, and it kind of goes both the ways. Sometimes yeah, it's actually pretty interesting, even the finances part of it. And in terms of resources, I would say I don't think any other university across India has the resources we do. So we're grateful for that. Yeah.
Okay, okay. Well, that's something really, really good. It works quite similar over here. Also, we receive some funds from our university, and we have to look for different sponsorships, or just well, we sometimes need to put money on the project. But well,
Yeah.
it's worth it.
Yeah.
So for here, well, how many of you guys are planning to go to the IREC competition? Um, yeah.
Yeah, so last year we had around 17 members coming for SA Cup. The team strength was roughly close to 40. So we basically, what we try to do is, I mean, logistically, it's not very feasible for, I mean, me to even pick everyone saying, I'll take 40 people to the competition now as a whole. So what we try to do every year is, whoever has contributed throughout the year kind of thing, and whoever is actually necessary for the team in terms of participating in the competition. For example, I'll be requiring two, three guys to assemble the avionics bay. I'll be requiring two, three guys to test my recovery systems. Then maybe five or six here and there to assemble the airframe. And based on that, and based on also the regulations on visa. So visa application happens in groups. So there's a limit on how many can I add to the group or how many can add to the group on the lower and upper bound. So based on those restrictions and based on the challenges we can possibly face, we decide a team size and then we fill in members to the team size. So this year maybe we are doing hybrid propulsion, so we'll be requiring more members over there. So probably we are hoping it's gonna be around 20, 25 people out there. So it's gonna be exciting this year.
Wow,
Yeah.
that's it's a
Yeah,
lot.
that's actually a lot. Yeah, it's a lot. We
Okay,
are operating at a team strength of 45 currently. Yeah.
okay. Well, a pretty
Yeah.
big team, actually. Um, well, also you said that. Well, what I could read, it was that it was your second time participating this year on spaceport. Um, do you guys have any competition in, well, any competition or any Asian competition different from spaceport that you can participate?
So there is an Indian competition that was just inaugurated this year. So the first edition of the competition hasn't happened yet. It is supposed to happen sometime during the second phase of next week. So during the fourth quarter of next week, or next year actually, not next week. That is a miscommunication. So during the fourth quarter of next year, ISRO, basically the Indian Space Research Organization, the government body for launching rockets in India, and there's a body called InSpace. So InSpace and ISRO in collaboration have inaugurated a rocketry competition in India. So this is supposed to happen in the fourth quarter of next year, and this is an opportunity for Indian teams to participate in that competition. And we didn't apply for the competition actually because we had a lot of timelines clashing. We had CANSAT USA, SA Cup, and there's another competition called CANSAT India, an Indian version of CANSAT USA. So we had timelines of all three clashing, and so we didn't feel like we can pull it off everything smoothly considering the workforce we have, the timelines we have. So we decided to not go ahead with that.
Okay, okay. Well, it's great that you do have and you do plan to participate. And well, you've just solved a lot of many questions that I have. I don't know if you guys have any question also for us. We can now open the time for people who have questions in the chat. You can ask. Or wow, there's a lot of supporting you guys also us, so that's great.
Yeah, a lot of our
You do
guys.
have a lot of
So
participation in your
how
well
is
in your country.
sorry? Okay, competition in our country. So in our country, as of this year, around 9 teams applied for IREC. So four got selected after the first one, basically after the submission of application. Primarily, these were the same teams which participated last year too. They include us. This university called IIT Bombay. So we're called IIT Madras. IIT is like kind of the centrally funded university, Indian Institute of Technology. So there's a team called IIT from IIT Bombay. Bombay is one of the most famous cities. We're familiar with it. So we, IIT Bombay, and there's a team from a university called Vellore Institute of Technology, VIT
Okay.
Vellore. They come for the competition. And then we have also Manipal Institute of Technology. So these are primarily the four teams that have been consistently coming to IREC. We are hoping for more competition actually from the upcoming years. We've been mentoring a few teams from different universities, considering we have experience of participating for a few years. So they are also trying to apply for the competition from next year onwards. So this is a dynamic in India in terms of rocketry and in terms of the competition.
Okay, okay. So well, the four of you guys are the ones who are leading. Um, Here's a question from the you. He says that if you can do flight tests there in India, like well here in
Uh,
Mexico, are just some points that are where we can do the flight test where are legal. So I don't know if it works the same over there.
yeah. So in India, basically the airspace restrictions are very strict. So like if you're flying anything above 300 meters, which is more than 250 grams in weight, you'll need permissions. You're not allowed to do that, and most of the airspace are restricted to government or bodies who are related to airport authorities or stuff like that. So surely my rocket is gonna fly above 300 meters and is not less than 250 grams in weight. So we can't do flight tests in India. But we recently got permissions to do one of our launches in India. So the details of which I can't disclose for the moment because we are still in the documentation phase. But we are planning to do one launch in India in ending of February. So we'll probably catch up with you guys over then. Yeah.
Well, if you guys have any videos from at that
Yeah.
moment,
Yeah. Yeah.
send it to us. We will
Yeah.
like to watch them.
Yeah. Yeah.
Um, Here's also another question. Well, for Space Dragons, what's the payload this year? Well, this year we're planning to do like how can I say it? Well, it's there are different sensors which are going to evaluate how the parachute and how everything works inside from the rocket, and also to test it, publish it, maybe in a social media in real time. We're to discuss details from that, and to evaluate how X-ray affects also during flight. So we're working a little bit with that. Our payload, it's well, as I can say, it's one of the areas that we need to work the most.